तो यूनिट 7 हम लोग स्टार्ट करने जा रहे हैं। इसमें हम लोग एक्सपोनेंट, लॉगरिथम और इंटीग्रेशन को हम लोग डिस्कस करेंगे। इस चैप्टर को स्टार्ट करने से पहले, जैसा कि टेक्स्ट बुक आपसे कह रहा है कि आप पहले अपने प्रीवियस नॉलेज को एक बार चेक कर लो। डिफरेंशिएट y इक्वल्स टू एक्स क्यू माइनस 5x अपॉन कॉस ऑफ x। वी हैव टू डिफरेंशिएट इट। सो हाउ वी कैन डिफरेंशिएट? We can differentiate it with the help of quotient rule. Right. So first of all, we will do the square of the denominator, and then denominator will be kept kept as intact, no change, and differentiate your numerator. So it should be 3x square minus 5, then subtraction minus, and then numerator will be intact, no change, and the differentiation of denominator, that is the minus of sine x. Now just simplify this, you will get your answer. Is it okay?
Oh, yes.
Can you try the question number 2? Determine dy upon dx in terms of x and y given that this. How we can find dy upon dx? How we can find dy upon dx? Mhm. Just tell me the first step of your calculation of your proceeding. The first step. I don't need the final answer. I need only the first step of your working.
So
What
इसमें
you will
क्या
do?
implicit differentiation करना है?
Exactly. This is the implicit differentiation. है ना? इसमें implicit differentiation करेंगे। चलो एक लाइन, फर्स्ट लाइन केवल आप मुझे बताओ, केवल फर्स्ट लाइन। हम्म
3y square dy by dx.
3y square dy over dx। देन
और फिर
ऐसे गाड़ी चलेगी? बताओ, ऐसे चलेगी गाड़ी अटक अटक के?
नहीं नहीं
नहीं चलेगी ना? नहीं चलेगी। इस तरह से मतलब आपने ऐसा कर भी दिया तो क्या ही फर्क पड़ जाना है। दूसरी बात, अच्छा ये भी सोचो कि इंटीग्रेशन के पहले आपसे डिफरेंशिएशन को एक बार फिर से कह रहा है, चेक कर लो बेटा एक बार। क्यों? मैं भी वही कह रहा हूं, बिना डिफरेंशिएशन के मास्टर बने आप इंटीग्रेशन को हाथ ही मत लगाना। ठीक है? क्योंकि डिफरेंशिएशन से ही पूरा आपका इंटीग्रेशन सॉल्व होगा। इसीलिए ये भी आपको कह रहा है कि पहले आप डिफरेंशिएशन के मास्टर एक बार हो कि नहीं चेक कर लो। तो इम्प्लिसिट डिफरेंशिएशन कैसे करते हैं? बहुत ही आसान है। आप डिफरेंशिएटिंग बोथ साइड करो। अब यहाँ पे लेफ्ट साइड में देखो, दो टर्म का सब्ट्रैक्शन है ना? डिफरेंस देखो, दो
हाँ
टर्म का तो u प्लस माइनस v फॉर्म का रूल क्या कहता है? इंडिविजुअली आप इसको भी डिफरेंशिएट करो, इंडिविजुअली इसको भी डिफरेंशिएट करो। अब एक्स वाई क्यू का जब हम डिफरेंशिएशन करने गए तो यहाँ पे दो फंक्शन का मुझे प्रोडक्ट भी दिखा, तो प्रोडक्ट का रूल लगाओ। प्रोडक्ट का रूल क्या कहता है? एक फंक्शन को हमने खाली छोड़ा, दूसरे को डिफरेंशिएट किया, तो वाई क्यू का डिफरेंशिएशन लिख सकते हैं 3y² इंटू डी वाई ओवर डी एक्स। लिख सकते हैं या नहीं लिख सकते हैं?
हाँ
प्लस, प्लस क्यों आ रहा है? अभी हम प्रोडक्ट रूल में ही है ना? अब हम वाई क्यू को लीव करेंगे, इंटैक्ट रखेंगे, नो चेंज, और x का डिफरेंशिएशन विथ रिस्पेक्ट टू x दैट विल बी 1। ये फर्स्ट टर्म का डिफरेंशिएशन हो गया। माइनस, अब सेकेंड टर्म में भी देखो फिर से मुझे प्रोडक्ट फॉर्म दिख रहा है, तो यहाँ पे फिर से मैं ब्रैकेट ओपन कर लेता हूँ, और y को मान लो आपने इंटैक्ट कर दिया, नो चेंज, तो साइन स्क्वायर एक्स का डिफरेंशिएशन क्विकली, साइन स्क्वायर एक्स का डिफरेंशिएशन क्विकली इन वन गो।
साइन का डिफरेंशिएशन cos
बोलो बोलो, बोलते जाओ। साइन स्क्वायर एक्स का डिफरेंशिएशन बोलते जाइए, देखो बोलते जाओ, बस मैं लिखते जाऊंगा, पहले रखो। हाँ जी, साइन स्क्वायर एक्स का डिफरेंशिएशन कॉस एक्स, और कुछ?
हाँ 2 cos x
2 cos x। और कुछ?
नहीं।
ऐसे अटक अटक की गाड़ी चलेगी तो नहीं होगा। अभी मैं आपको डिफरेंशिएशन पे ही रोक लूंगा, फिर मैं इंटीग्रेशन में इन्हीं नहीं करवाऊंगा, क्योंकि है कमी है यहाँ। देखो सबसे अच्छा एक बात बताओ, जब आप इसको डिफरेंशिएट करने जाओगे, राइट, तो सबसे पहले आपको कौन सा फंक्शन आपको रेसिस्ट करेगा, कौन सा फंक्शन आपको रोकेगा? साइन या स्क्वायर? कौन रोकेगा आपको? साइन भी एक फंक्शन है, स्क्वायर भी अपने आप में एक फंक्शन होता है ना, स्क्वायर फंक्शन, स्क्वायर रूट फंक्शन, क्यूबिक फंक्शन, क्यूब रूट फंक्शन। तो जब आप इसको ब्रेक डाउन करने जाओगे, तो सबसे पहले कौन सा फंक्शन आपको रेसिस्ट करेगा, रोकेगा? साइन या उसका स्क्वायर? स्क्वायर रोकेगा या
स्क्वायर।
साइन रोकेगा? पक्का? आप इसको ऐसे भी समझ सकते हो ना, डी ओवर डी एक्स इट इज साइन एक्स होल स्क्वायर। हम समझ सकते हैं ना, साइन
हाँ।
स्क्वायर का मतलब बताया था आपको, इट इज नथिंग बट स्क्वायर ऑफ साइन एक्स। तो बताओ, अब यहां से तो क्लियर ही है, सबसे पहले आपको कौन रोकेगा? सबसे पहले आपको ये स्क्वायर रोकेगा, उसके अंदर बंद है साइन एक्स। तो यहाँ तो ये वेरिएबल है, ये तो वेरिएबल है, और वेरिएबल रेज टू पावर कांस्टेंट है। तो पहले x रेज टू पावर n का रूल लगेगा, n इंटू एक्स रेज टू पावर x के अंदर क्या लिखा हुआ है मुझे पता नहीं, मुझे तो दिख भी नहीं रहा है, मुझे तो उसका एक्सेस भी नहीं है। 2 माइनस वन दैट इज द 1, सो इनटू, अब ये पावर का खत्म हो गया डिफरेंशिएशन, आपने उसको ब्रेक
हाँ।
डाउन कर दिया। अब आप उसके बेस को एक्सेस कर सकते हो, उसके बेस को देख सकते हो, उसको डिफरेंशिएट करना है। तो साइन एक्स का डिफरेंशिएशन कॉस एक्स, तो ये होगा ना 2 साइन एक्स इंटू कॉस एक्स। उसके बाद फिर साइन का भी हो गया, अब उसके अंदर क्या है, एक्स, तो एक्स का एक्स के रिस्पेक्ट में क्या हो जाएगा, 1। तो ये हो गया पूरा आपका डिफरेंशिएशन। तो और ये 2 साइन एक्स इंटू कॉस एक्स को हम साइन 2x भी लिख सकते हैं, है ना, यूजिंग द आइडेंटिटी यू मे राइट साइन टू
अच्छा।
एक्स।
हाँ हाँ।
तो ये हो गया आपका साइन 2x। अब शॉर्ट में ये भी लिख सकते हो। फिर प्लस, अब साइन स्क्वायर एक्स को इंटैक्ट कर रखो, नो चेंज इन साइन स्क्वायर एक्स। और y का डिफरेंशिएशन विथ रिस्पेक्ट टू x क्या होगा? y का डिफरेंशिएशन विथ रिस्पेक्ट टू x क्या होगा? y
वाई
का
का
डिफरेंशिएशन विथ रिस्पेक्ट टू x क्या लिखें?
तो ये वाई क्यूब का होगा, 2y² dy बाई डी
अरे
एक्स।
भैया y क्यूब नहीं है, y है केवल, y का डिफरेंशिएशन विथ रिस्पेक्ट टू x, dy ओवर dx, दैट्स ऑल। जैसे x
हाँ
का हम
हाँ।
क्या लिखते हैं, dx अपॉन dx, वो 1 बन जाता है, लेकिन ये 1 नहीं बनेगा, फिर dy अपॉन dx आपका रह जाएगा। यहां तक समझ में आया? कोई डाउट है यहां तक तो बताओ।
नहीं, ठीक है।
अब ये तो हुआ LHS का डिफरेंशिएशन केवल, this is the differentiation of your LHS only. Now we have to differentiate our RHS also. So equals to, इसको differentiate करने जब जाओगे तो यहाँ पे प्रोडक्ट फॉर्म लगाएंगे हम लोग u इंटू वी का। तो पहले हमने y को मान लिए इंटैक्ट रखा, नो चेंज, cos x का डिफरेंशिएशन माइनस ऑफ साइन x, है ना, और x का 1, फिर प्लस, अब cos x को खाली छोड़ दिया, इंटैक्ट रखा, और y का डिफरेंशिएशन dy ओवर dx, है ना। ये पूरा एक्सप्रेशन आप यहाँ पे चाहो तो एक अच्छे से तरीके से लिख सकते हो, 3xy² dy ओवर dx प्लस वाई क्यूब दिस माइनस y इंटू साइन 2x प्लस साइन स्क्वायर x dy ओवर dx should be equals to माइनस वाई साइन एक्स प्लस कॉस एक्स डी वाई ओवर डी एक्स। यहां तक ठीक है? कोई डाउट है? इसके बाद आप क्या करोगे, डी वाई अपॉन डी एक्स को, डी वाई अपॉन डी एक्स के टर्म्स को कलेक्ट करेंगे किसी एक साइड, और बाकी सारे दूसरे टर्म्स को अदर साइड हम लोग शिफ्ट कर देंगे, और डी वाई अपॉन डी एक्स को हम सब्जेक्ट बना लेते हैं, दैट्स द इम्प्लिसिट डिफरेंशिएशन। कोई डाउट है?
नहीं।
चलो, तो देखो, अब होमवर्क में पहले ये क्वेश्चन लिख लो, इसको डिफरेंशिएट करना, प्रैक्टिस बहुत जरूरी है। फिर से मैं कह रहा हूं, अगर डिफरेंशिएशन के मास्टर नहीं हो, डिफरेंशिएशन करने में अगर आपको 1 मिनट, मतलब एक बार भी सोचना पड़ रहा है अगर, है ना, कि करें ना करें, सही कर रहे हैं गलत कर रहे हैं, तो भैया इंटीग्रेशन की कहानी तो उससे कई गुना मुश्किल हो जाएगी। तो ये 2 क्वेश्चन आपके होमवर्क के प्रैक्टिस के लिए लिखो, हालांकि सॉल्व किया हुआ है बट आप पहले खुद से करना, और फिर उसको वेरीफाई कर सकते हो। ठीक है, लिख लिया? इमेज पिक्चर भी ले सकते हो।
हाँ चलिए।
करेक्ट। ना, इंटीग्रेशन एज एंटी डिफरेंशिएशन, देखो कह भी रहा है कि भैया इंटीग्रेशन कुछ नहीं है, डिफरेंशिएशन का रिवर्स प्रोसेस है। अब बच्चे को अगर डिफरेंशिएशन ही नहीं आएगा तो उसका रिवर्स कहाँ से आएगा? ठीक है।
हाँ
एंड
सही।
डिफिनिट इंटीग्रल, तो डिफिनिट इंटीग्रल भी देखेंगे, पहले सिंपल इंटीग्रल देखते हैं। वन मोर थिंग, डिफरेंशिएशन का ज्योमेट्रिकल मीनिंग क्या होता था? क्या देता था डिफरेंशिएशन? स्लोप देता था या ग्रेडियंट देता था, है ना? उसी तरह से इंटीग्रेशन का ज्योमेट्रिकल मीनिंग क्या होता है? इंटीग्रेशन का ज्योमेट्रिकल मीनिंग होता है एरिया। इट विल गिव यू द एरिया, राइट? चलो,
अच्छा।
चलो जी, यहाँ पे देखते हैं इन्वेस्टिगेशन वन, थोड़ा सा यहाँ पे स्टडी करेंगे, है ना? क्या कह रहा है? आपके पास एक ग्राफ है जो कि y इक्वल्स टू एफ डैश एक्स का है। द ग्राफ शोज द डेरिवेटिव फंक्शन, ये एफ डैश एक्स का ग्राफ है, ये एफ एक्स का ग्राफ नहीं है। बेस्ड ऑन दिस, बहुत इंपॉर्टेंट है ये आपके एग्जामिनेशन पॉइंट ऑफ व्यू से, डिफरेंशिएशन में आएगा ये, डिफरेंशिएशन वाले टॉपिक में भी। ओवर व्हाट इंटरवल इज एफ एक्स इंक्रीजिंग? चलो इसका आंसर करो। इस ग्राफ को देखो जो कि एफ डैश एक्स का ग्राफ है, इसको देखकर आपको एफ एक्स पर कमेंट करना है। यू हैव टू कमेंट ऑन एफ एक्स, है ना? ग्राफ एफ डैश एक्स का दिया हुआ है और कमेंट करना है एफ एक्स पे। क्या कमेंट करना है? ये फंक्शन इंक्रीजिंग कहां पे है और ये फंक्शन डिक्रीजिंग कहां पे है। चलो सोचो, क्वेश्चन समझ में आ रहा है ना? क्या पूछ रहा है वो, क्या दिया
हाँ
है और क्या पूछ रहा है? एफ डैश एक्स का ग्राफ देके एफ एक्स का आपसे पूछना चाहता है कि ये फंक्शन इंक्रीजिंग कहां पे है और डिक्रीजिंग कहां पे है। चलिए सोचिए और बताइए।
um from E to F.
From E to F it is increasing. How?
Yeah,
How? Can you
because
explain your
the
thinking?
gradient's positive.
Sorry?
The gradient's positive.
Gradient is positive. See, if you find the gradient of this curve, you will get f double dash x, right? If you are looking the gradient of this function, this given graph, so this is the f dash x is given, and if you are observing the gradient of your f dash x, it means you are observing your f double dash x, isn't it?
Okay.
अरे बात समझ में नहीं? तो
Yeah.
हमें तो एफ एक्स के बारे में कमेंट करना है ना। वी हैव टू कमेंट फॉर एफ एक्स, नॉट एफ डबल डैश एक्स। हम्म। चलो, अब मैं बताता हूं। डू यू नो दैट a function is increasing? A function will be called as increasing when either if you increase your x, your y should increase, or if you decrease your x, your y should decrease. Do you know this? This will be called as increasing function, right? Now, think over dy over dx. What does it mean? If I have increased my x, let's see. If you have increased your x, dx will be positive or negative? Positive.
Yeah.
If your x is increasing, the change in x will be positive. If you do x final minus x initial, obviously you should get the positive, isn't it?
Yeah.
So the denominator is positive. Similarly, what about the numerator? You are saying that if your x increase, your y should increase. You are telling that if your x is increasing, your y should increasing. So it means your y final minus y initial should also be positive, isn't it or not? So positive upon positive, what you will get? You will get the positive,
Yes.
isn't it? So this is the another criteria. Wait, wait, wait. So now think. and link in reverse manner. If your dy upon dx is positive, if your dy upon dx is positive, can we say that function is increasing? Can we say? I think you know this also.
Yeah.
अरे इसको ले जाओ भाई. Similarly, if dy upon dx is negative, it means बेटू दोनों यही मामा बुला रही थी. अरे इसको ले जाओ. लो खिला दो बेटू. ये लो. ठीक है. Similarly, if your dy upon dx is negative, so can we say that dfx should be decreasing?
Yes.
ये आपको पता भी है, आई थिंक, है ना?
हाँ.
तो भाई क्या प्रॉब्लम है यहाँ पे? अपने ग्राफ को देखो, एफ डैश एक्स का ग्राफ आपको दिया हुआ है ना. आप बस इतना देखो, आपका फंक्शन, आपका एफ डैश एक्स कहाँ पॉजिटिव है, बताओ. किस रीजन में आपका एफ डैश एक्स पॉजिटिव है? इन विच रीजन योर एफ
Between
डैश
B
एक्स
and
इज
C.
पॉजिटिव? बिटवीन बी एंड सी, करेक्ट. इस रीजन में देखो आपका एफ डैश एक्स पॉजिटिव है, इसका मतलब एफ एक्स इंक्रीजिंग
हाँ.
है ना. किस रीजन में आपका एफ डैश एक्स नेगेटिव है? नेगेटिव. सो इस ए टू बी एंड सी टू डी, तो इसका मतलब इस रीजन में आपका ग्राफ क्या होगा?
Negative.
डिक्रीजिंग होगा. कह सकते हैं,
Hmm.
नहीं कह सकते हैं? तो फर्स्ट पॉइंट क्लियर, सेकंड पॉइंट इज क्लियर. The third one, describe the nature of each of the points A to G on the graph of fx and explain your answer. अब क्या कह रहा है? A से लेकर G तक आपके ग्राफ में जो पॉइंट्स शो किए गए हैं, उनके बारे में कुछ कमेंट करना है ना? ये चलो मैं ही पूछ लेता हूँ डायरेक्टली. आप इस एफ एस एक्स के ग्राफ को देखकर क्या मुझे स्टेशनरी पॉइंट्स बता सकते हो? इनमें से कौन कौन पॉइंट स्टेशनरी पॉइंट्स होगा? Can you tell me which points are to be stationary points after looking this f dash x graph?
E, F, G.
E, F, G. Why? Can you explain?
Because they're the turning points.
Turning points of what? Fx or f dash x?
O, F dash X.
But we are looking for turning points of fx,
Okay.
isn't it?
Hmm.
So obviously your answer is incorrect.
Oh, so then would it be like, so there'd be a turning point at A, B, C, D.
Exactly. So your turning points are A, B, C, and D. Why? Can you explain it now? Because at these points your f dash x is 0 and the turning points are nothing but the point at which your dy upon dx is 0, isn't it?
Hmm.
So these are your turning points of your fx. Now the problem is not solved. We have to work for the nature of these turning points. It means, are you there?
Sir, one second.
Mhm.
Oh, yes, sir.
So basically, the problem is not still solved completely. We have to find the nature of these stationary points. It means you have to find these stationary points are the point of local maxima or the point of local minima or the point of inflection. So how we can classify the nature of these turning points? Please think.
You
What are
double
the,
differentiate and then you put in the
so
point.
how you will do the double difference? You have all
No,
the
you can draw the
information.
second derivative graph.
Okay. How you will draw the second derivative graph? Can you discuss? Can you tell
Where
me?
the turning points like E, F, and G, those become the x-intercept.
Please see. No, we have some other method also. The very simple method is, at the point of local maxima, at the point of local maxima, the F
The
dash
gradient
x
goes from
sign.
positive to negative.
Yeah, it should go from positive to negative. Similarly, for the local minima, it should go from negative to positive. Now, please see, at point A, you don't have any information, right? You don't have any
It goes from
information.
positive to negative, right?
How I can say it has come like this or it has come like this? How you can say? Is it given?
Okay. No.
Is it given? No. It may come in this way also. It may come in this way also. Why not?
Hmm.
So can we say can we say guaranteed that with guarantee that A is the point of local maxima or local minima? No, we cannot say because we don't have any information for the A, complete information for A. So we can comment for the B. Please tell for B. Is it a point of local maxima or local minima?
B goes from negative to positive, so maximum.
B is negative to positive. See, negative to positive.
Yeah, that's what I said.
So it should be minima, not maxima. If you are going
Oh,
from,
okay, okay. Oh, yeah, yeah, okay, okay, I got it. Yeah.
yes. What about the C?
Yeah, C goes from positive to negative, so maximum.
Exactly. This should be your maximum. What about this D? Not complete information you have, right?
Hmm.
You cannot say guaranteed that, okay, what it is. Okay. So describe the nature of each of the points A to G of the function fx. Explain your answer. We have already explained. Now, over which interval of fx it is concave up? Now, we have to work.
Concave up is between A and O for fx.
No, no, no. Tell me the concept first. How we decide the concativity of the curve? How?
Like for this one, is it between A and B, like it's facing
Wait,
off
wait,
close?
wait. I don't need the answer. We are discussing the curve. See, for the concativity, you have to find the double differentiation. And if
Hmm.
it is positive, then it is upward concave. And if it is negative, it is downward concave.
Hmm.
Right? This is the okay. What is the meaning of this double differentiation? It means the differentiation of the differentiation. It means the gradient of this f dash x. It
Huh.
means the gradient of your f dash x, right? See, this is the f dash x, and if you look the gradient of this f dash x, it means you are looking the d2y upon dx2, isn't it? It
Yeah.
means you have to see where the gradient of this f dash x is positive, where it has the positive slope. Can you tell me where it has the positive slope? See, in this region, I think this is the negative slope, right?
Hmm.
And from B to F, yeah, sorry, this is the E. E to F, it have a positive slope, right?
Hmm.
So in this region, it should be concave up. Similarly, from F to G, its slope is negative. We can say in this region, it has the concave down, right? And after this G to D, again, it is positive slope, so it is concave up. Have you understood how we see the concavity of the curve?
Yeah.
Can we decide the how we can decide the point of inflection? So the point of inflection are those points at which the concavity of the function changes, right? Do you know the point of inflection?
Hmm.
Point of inflection, there are two kind of point of inflection. One is the horizontal point of inflection, another is non-horizontal point of inflection. You can see the concavity. Point of inflection, the point where the function is no this. Yeah, see this one. Inflection point is a inflection point on a is where a curve change from concave upward to concave downward or vice versa. Is it okay? So This is the inflection point of inflection. Negative. Sorry, actually, wait. So, okay. Have you understood? Have you understood this discussion? Okay. Now, अब हम लोग किसकी बात करेंगे? डिफरेंशिएशन, इंटीग्रेशन की या एंटी डिफरेंशिएशन. तो इंटीग्रेशन दो टाइप के होते हैं. वन इज अ डिफरेंट इंटीग्रेशन. One is the definite integration. Integration are of two kinds. One is the indefinite integration and another is the definite integration. Let me discuss. Now, see, do you know what is the dx? What is the dx? Dx is the small part of x, very, very small segment of x, isn't it? And if you
Hmm.
integrate, this is the meaning of integrate. So if we integrate a small part of x, we will get the complete x. Similarly, if we integrate a small part of y, we will get the complete y, isn't it?
Yeah.
Now, suppose we have the integration of differentiation of sin x. Do you know the differentiation of sin x? D over dx sin x is equals to cos of x, right? If we shift this dx to other hand side, what I can write? D of sin x should be equals to cos x into dx, isn't it?
Hmm.
Okay. Now, if we integrate both sides, so what we can write? See, as I explained, dx becomes x, dy becomes y. So d of sin x, it means if you add small parts of your sin x, if you add all little parts of sin x, you will get the complete sin x. And this side, you will get the formula cos x into dx. Is it okay? So in
Oh,
this way, we can understand that integration is the reverse process of
differentiation.
differentiation. Let us see another example, a very simple example. I think you must know the first formula in your differentiation, d over dx of x raised to power n. It is n into x raised to power n minus 1, right?
Hmm.
If we shift this dx to other hand side, what will we get? We will get d of x raised to power n equals to n into x raised to power n minus 1 into dx. Now, if we integrate both sides, what will happen? So, see, if you integrate small parts of x raised to power n, if you add small parts of x raised to power n, obviously you will get x raised to power n, right? If we add small little parts of x raised to power n, so we will get the complete x raised to power n. And
Huh.
see, in this integration, this n is the constant. How I can say this n is constant? Because my variable is x. This dx is telling me that x is my variable. So n can be taken outside of this integration. So you will get x raised to power n minus 1 dx. Now, for the formula, I can shift this n to the other hand side. So I can write x raised to power n upon n is equals to integration of x raised to power n minus 1 dx. Have you understood till here?
Oh, yeah.
But actually, this formula, if you leave your formula in this form, or if you remember your formula in this form, it looks little difficult, it looks little, complicated. So right now I have x raised to power n minus 1 dx is equals to x raised to power n upon n. So I want my formula in terms of x raised to power n to simplify the expression. So what I am doing, I am increasing my n here by 1. So similarly, do the same thing in the right hand side. So you will get x raised to power n plus 1 upon n plus 1. Have understood this formula, where and how it has derived?
Oh yeah, okay.
Now, one thing I want to ask from you, most of the time you have seen that it should have some c as a unknown integral constant,
Yeah.
right? So can you explain or can you think why it is necessary and what is the meaning of this unknown constant c?
Serious because like in differentiation, if you have like x squared plus 9x plus 5,
Correct,
like this
correct,
5 goes away and
correct.
you don't know what to
Yeah.
do.
Similarly, see, suppose you have y is equals to x raised to power q, or you have y is equals to x raised to power q plus 8. If you differentiate, then both will give you the same differentiation, that 3x squared, and here also you will get y is equals dy over dy is equals to 3x squared. So now we are thinking in the reverse manner. Suppose we have the differentiation as 3x squared, and now we have to think for y in the reverse. So how I can say it should terminate here or it should terminate here? Are you getting the point? So that's
Yeah.
why we have to add a constant c, which can be calculated, which can be found if we have some other known given conditions. Is it okay? So first of all, we should have some formulas based on with the same logic as we have derived for some basic like x raised to power n, we have derived for the integration of cos x dx, right? So just reverse process. While doing the reverse process, we can have so many formulas for integration as well, right? But I will suggest you to not the remember formula blindly, right? Whenever you see the formula of integration, you must see the formula of differentiation side by side. So always remember the differentiation, always refresh your differentiation formula and do the reverse in your mind. If you remember both the formulas, like differentiation as well as integration, then at the time of examination, there is a very high probability, there is a high chance that you may get confused. Are you getting my point? So you have
Yeah,
to
yeah.
remember the differentiation only. Let me show you the formulas. So we have discussed what is the meaning of indefinite integration. So why this is called the indefinite integration? Because we don't know. See, if we have this differentiation dy over dx, so will it terminate at y is equals to x cube or will it terminate at x cube plus 8? You are not sure. You're not definite that my y is this or this. So that's why we have to add a known c, and this method and this way of integration or this way of finding y will be called as indefinite integration. And this is very important concept for your next chapter, that will be your differential equation, right? So that's why we have to discuss these things very carefully. Any doubt till here?
No.
Okay. So we have understood what is the meaning of integration. To add up, it is a reverse process of differentiation. What is the meaning of indefinite integration? What is the meaning of constant of integration? Why this is necessary? So we have discussed these things, right? Any problem?
No.
No. Okay. So based on this, okay. So the first formula which I have given you is integration of x raised to power n dx is equals to x raised to power n plus 1 upon n plus 1 plus c, right? Can you work for a smaller question like integration of x cube dx? Can you integrate it quickly?
Well, like x to the power 4 over 4 plus 3.
Correct. Can you integrate 1 over x square?
X to the power of minus 1
Mhm.
over minus 1.
Can you integrate 1 over x?
Uh, what just 1?
See, we have a limitation for this formula. You cannot apply for n is equals to -1. This is not true for -1. Why? Because your denominator becomes 0.
Yeah.
And this is not a valid statement in mathematics. So you cannot integrate 1 over x with the help of this formula, isn't it?
Hmm.
So how we can integrate this? So if you have remembered the differentiation of, okay, you don't have remembered the differentiation of ln x. Okay, let me give you this formula. If you differentiate dy dx of ln x, ln means base is e. So the differentiation of ln x is 1 over x.
Mr. What's ln?
Okay. ln is basically logarithmic function whose base is e. We will see very soon, right? But if you write it together, it will make it complete discussion based on this x raised to power n. So if we have to integrate, it means if we integrate this, you will get this. So the integration of 1 over x dx should be ln x, not log x. Base should be e plus c. You should write this formula in addition to the above one to complete this discussion based on x raised to power n, because this formula is not applicable for x raised to power -1. Is it okay? Any doubt till here?
Okay, yeah.
Can we move?
Yeah.
One more thing you can see in differentiation, why I always say that differentiation we are going to break down. Because in the differentiation, we will see the differentiation of x raised to power n is n into x raised to power n minus 1. In differentiation, your power decreases gradually. In integration, your power increases gradually. So that's why differentiation is called as a breaking process, right?
Yeah.
Okay. Hmm. Suppose we have to integrate 20x cube dx. What it should be? Integration of 20x cube.
Um, 20x 4 over 4.
Hmm. Please see these three concepts. Any doubt till here? See, the last one is very simple. You have various function in addition or subtraction. Then you can integrate separately.
Yeah.
Is it okay? Okay. This one, the same thing. If you have two functions added or subtracted, and if they are in integrable form, if you know the integration of individual functions, please see, I'm repeating again. If you know the integration of individual functions, then you should integrate separately. Otherwise, you should think for some alternative options. Suppose you are not getting the integration of fx individually or gx individually, then it will be not a wise decision to separate them individually. You can take the other approach, right?
Yeah.
Okay. Now I have already see, as I told you, whenever you have the formula for integration, you must have the formula of differentiation in your side by side. And you have to remember, you have to refresh this one. You have to do the reverse in your mind. Don't remember this one. Reverse in your mind. So if the differentiation of sin x is cos x, it means the integration of cos x will be sin x.
Yeah.
If the differentiation of cos x is minus sin x, it means integration of minus sin x dx will be cos x, but you need in terms of sin x. So if you write integration of sin x dx, you can shift this minus to other side. So it will be minus of cos x.
Huh.
Hmm? Right. Similarly, differentiation of tan x is sec square x. It means integration of sec square x will be tan of x. So again, I'm repeating, please remember your differentiation formulas by heart, right? You should not remember the integration formula which are linked with differentiation formulas directly. Otherwise, you will get confused. Now, please see the example number 1. Find the following in different integration. I think first one is very simple. We have already discussed this. The
Yeah.
second one is also very simple, right? Example number 2. Integrate the following. Have you any doubt in these two?
Oh no, it's fine.
Example number 3. Integrate this and this. So if you know see, they are added. There are two functions which are added or subtracted. So if you can integrate them individually, then it will be wise decision to separate them. Otherwise, you have to think separately or you have to think alternatively. I think right now both you can think for the second part. Can you tell me? Can you think for the second integration?
What? So the first one read theta 3/3.
Mm-hmm. Okay. The next one?
2 tan cubed over 3.
No.
Wait, the
Yeah. What it should be?
Mister, what's the differentiation of tan?
Differentiation of tan. dy dx tan x. dy dx tan x is equals to sec square x.
No, like what differentiates into tan?
That you have to think. Okay, no problem. So we will. I think time is getting over. Yeah. See what we can do quickly. So if we separate them, so you should write integration of theta square d theta minus 2 times integration of tan square theta d theta. But unfortunately, I don't know any function, I don't know any standard function whose differentiation is tan square theta. Like, the sec square is the differentiation of tan.
Hmm.
Sec square x is the differentiation of tan. But unfortunately, we don't know any function whose differentiation is tan square x, right? Unfortunately, we don't know this. You also don't know this.
Hmm.
And this is the general case. You will have such a situation in which you will not have such function easily known to you, whose differentiation is tan square x. If it is the case, then easily you can integrate tan square x, you will get your answer, right? So what we can do here, we can try to convert this tan square theta in my integrable form. So for that, we have sec square theta minus tan square theta is 1. So can we write that tan square theta is equals to sec square theta minus 1?
Yeah.
This will be integrable as theta cube upon 3 minus 2. And I am writing here sec square theta minus 1. Now, please rethink. If we bifurcate it again, so this is the theta cube upon 3 minus 2. And now, if you bifurcate them, you will get sec square theta d theta minus integration of 1 d theta, isn't it?
Hmm.
And fortunately, we have the sec square x as a differentiation output. And let's reverse this tan x. So it means we know the different integration of this one as tan x. So it should be theta cube upon 3 minus 2. And it should be written as tan theta minus. The integration of d theta will be theta, right? So now you can simplify them. You will get your answer. Have you understood it? Let's see. So this is
Okay,
the
yeah.
basic method or basic idea to think in integration. You have to become the master of your differentiation first, right? Any doubt? You may verify the books method also. Yeah, they have substituted like this, and then it should be done. Okay, so we will continue this discussion in the next class also. Okay.
Okay, sir.
Okay, thank you. Take care.
Goodbye,
Bye.
sir.